So, good afternoon, students. So, I think some problem is there in the sheet for the attendance. So, you don't worry. Keep on marking your attendance in the stipulated time. I will correct the code later on when there will be a time between the two classes. Okay. So, I'm just starting the lecture ahead, and this particular lecture, after completion of introduction and importance of statistics and biostatistics, I am starting the next lecture, that is the collection, classification, and tabulation. So, in this particular lecture, we will be how a data is collected, how it is classified, and basically how to tabulate, that is, how to make it. So, in the very introduction part, I have told that in our previous chapter on introduction and importance of statistics and biostatistics, it becomes quite clear that one important thing, that is the data is the integral essence of this subject. And without this data, we cannot proceed. So basically, uh, what I want to tell to all students is there is no need to write your name in the WhatsApp. You keep on marking your attendance as it is, as you do earlier. Okay, and I will correct it. Okay. So basically, now in this chapter, we will learn that how this data is collected, classified, and tabulated. When the data is so much important in statistics, it becomes very necessary to understand that what data is. So before starting this collection, classification, and tabulation of data, we will just try to understand what data means and what are the different types of data. Okay. So in this particular session, in first session, I will try to cover the part what data is, what are the different types of data available with us, and then I will try to cover up some of the part of how to collect the data. And in the second session, we will be completing this topic. Okay, and let's try that how much can be completed. Otherwise, we will take it from the next lecture. So the word data is a Latin word. Mentioned it over here. Now that it is a Latin word, I am having a call just sorry for that. Details. So what I was telling is that data is a Latin word, and it means anything that is given to us. Okay. So what it means is in Latin, this data means is that anything which is given to us constitutes. Now, different sources have defined the data in different manner, and if we go to this box particularly, that is the definition of it is not the definition of statistics, it is data. Okay, and so basically this definition of data has been given in Webster Dictionary, Oxford Dictionary, and there is a definition from the UNESCO, then definition of modern economics, then the definition given in McGraw-Hill Encyclopedia of Science and Technology, and then one is given by the Committee on Data for Science and Technology, and other is given by the Schumann. So if you go through these, if you see what Webster Dictionary says, something given or admitted constituting a facts or principle granted or presented that upon which an inference or argument is based. So ultimately we are going to take out the inference out of it. So similarly, some other people also try to define this data. And what from this box we obtain or extract out is that when it is applied to different parts, that is, if it is a scientific part as per the Encyclopedia of Science and Technology, that is nothing but the numerical or qualitative values derived from scientific experiments. And if we go for this committee on the data for science and technology, it is the crystallized presentation of the essence of scientific knowledge in the most accurate form. So different definitions have tried to define data in context to the areas in which it is. Okay. So now I will be taking up the types of data, and this is very much important and you should concentrate on this because type of data you will encounter many a times during this particular course of biostatistics, and it will make your foundation that which type of statistics you should apply on particular so first one is the this data can be of different types and based on how it is defined in relation to the factor. These factors vary and accordingly our class this definition and the types of this data varies. Okay, and these are first of example is time. So this type of data is represented in relation to time. So basically there are two types of data in relation to time. First one is the time series data. What is the time series data? The data which is recorded in a chronological order across the time. Okay, is referred to as time series data and it takes different values at different times. So when you get encounter with data in which some chronological order is there, so that type of data is the time series data. So I am getting so many queries from students regarding the attendance. So you don't worry, I will be taking care of it in the between the two lectures when I will be getting the time. I will see what is there. Okay. You just mark your attendance both from the form and you can also leave a message on the WhatsApp. So we were discussing about the data, that is the types of data based on the time. Now another is the cross-sectional data based on the time. And what is the cross-sectional data? That is, this refers to a data for the same unit or for different units at a point of time. That is, at a particular point of time, what is the value? Okay, so that type of data is known as the cross-sectional data. Now, data can also be divided or different types can be made on the basis of location. That is location is specific, based on the geographical location. So say for example, we have some data from the different countries. So we can say that this is the population of India, this is the population of Sri Lanka, this is the population of Pakistan, or this is the population of America. So accordingly, the geographical location is being tagged with the data. Okay, and such type of data is known as location specific data. Now, mode of generation. That is, data can also be of different types based on the its generation method. That is how a data is generated, and it is very important from the collection of data point of view. That is the collection of data which we are going to study in this particular lecture in the next session. That is dependent on the mode of generation. That is how we want to generate data. So the mode of generation can generate a primary data. So what is the primary data? The data are primary when obtained by the experiment or observation designed for the measurement. That is in this particular how it is obtained. That is either by the observation or by the experiment. Okay, and the data obtained first hand from the individual by direct observation, counting and measurement or by interviews or mailing a questionnaire are called primary data. That is how you can collect a primary data. That is directly the first hand data available with the individual. Either you observe it, you count it, you measure it, or you make interviews, or you just disseminate the questionnaire and collect the primary data. So these are the different methods of generating data, and such data which is first hand is known as primary data. Now comes your secondary data. The data collected initially for the purpose and already published. Okay, that is these are generally already published data, and sometimes it is unpublished data available also. Okay, and these are used later for some other purpose are referred to as secondary data. That is already the data is available take out that data and use it for some other purpose. So that type of data is known as the secondary data. Now the secondary data can be divided into two parts. One is the derived data and other one is the theoretical or predictive. So derived or reformative data is one. That is the data derived by combining several primary data with the aid of a theoretical model. So for example, a particular model wants the age and the weight to calculate certain parameters. Some primary data you will get the age of those individuals. Other primary data you will get the weight of those individuals. So you combine them, reformat them, and derive the data that is known as the secondary data that can further be used for the study. Then, what is the theoretical or predictive data? These are derived by the theoretical calculations. That is, you have certain parameters available with you. You have some fundamental constants as well as the mathematical operations available with you. Say, for example, you say that the carving interval is equal to the service period plus gestation period. So, if you add all the service periods with the gestation period of the respective animals, you will get data about the carving interval of the animals. So, such data is known as theoretical and predictive data. It is predicted from the primary sources. Now, it also the data also depends upon from the nature of the quantitative values. That is, what is the nature of that quantitative value? So data can be determinable data. That is, data on a quantity which can be assumed to take a definite value. That is, it takes only a definite value. Say for example, if you say that number of teats in cattle. So number of teats in cattle takes a definite value. Okay, that is, there are four teats. So whenever you will be going for any cattle, although in some of the cattle due to some genetic defect or some other problems, there may be less number of teats, but that is a outlier data. So these determinable data are those which can be determined easily that this will take this particular definite value. Say for example, the gravitational constant 9.8 meter per second. Okay, so like that, this determinable data have a definite value. What is the stochastic data? Stochastic data is the one which takes fluctuating values. That is, whenever you will be measuring them from one individual to other, and this is the most common type of data available in the population. That is when you measure those values height, for example, you measure from one individual to other. So it will vary from one individual to other as well as from one sample to other in a population. And such type of data is known as stochastic. Now, data can also be divided on the basis of the terms of expression. So, on the basis of expression, a data can be quantitative data. Okay, quantitative data. And this particular quantitative data, these are uh, these are measures of quantities expressed in terms of well-defined unit. Some people are saying that there is a problem in audio. Okay, so I'm just see on my end that whether the audio is having a problem. Just give me a time. Yes. Okay. Okay. Okay, so I think I should be more closer to the microphone so that there will be less problem with the audio sound. And give me 1 minute, I will be just back. Okay, students, let us again start the lecture. And if you feel that there is uh, much of disturbance and you are unable to listen, so kindly let me know. Okay, about that. So this quantitative data, these are measures of quantities expressed in terms of well-defined units, changing the magnitude of quality to a numerical value. So one essence is the numerical value, okay, and most data. This is very important. So most data in biological sciences are quantitative in nature, okay. So it results from, say for example, age of a person, price of a commodity. I have already told you in my previous lectures that a normally distributed data are most of the time quantitative in nature, and their quantity can be measured in a numerical value, and that numerical value remains on a continuous scale. That is, we can have infinite possible number of observations from a quantitative data. Okay, then comes your semi quantitative data. This type of data consists of affirmative or negative answers to posed question concerning the, that is, what is affirmative or negative answers we get in that. So in biology, you might be encounter with the some of the classification of organisms based on yes or no. That is, this particular part is present or absent. Okay. So such type of data which can assume two type of answers, that is whether present or absent, are said to be in the semi-quantitative data. Okay, and they follow the binomial distribution. This type of distribution we will be studying in our coming classes. Okay, then comes your qualitative data. So qualitative data, they are expressed in terms of definitive statements. Okay, that is, they do not take upon the continuous numerical values, and they are qualitative in nature. That is, they establish some characteristic of observation like quality or some attribute. Okay, so particularly when you measure the quality or the attribute, we go for the qualitative. Okay, and the example is sex of a person or the color of a person or intelligence of a student. Okay, so such type of data generally are nominal or the ordinal type of data. This we will be studying in the coming data types. Then data can be further be differentiated into different types based on the mode of presentation. That is how a data is presented to you. That is, it can be numerical data. If a data assumes the numerical values, then it is said to be numerical data. Okay. Okay. Then comes your graphic data. If a data presented in a graphic form or in the form of models, then it is said to be a graphic data. So you can very well understand that when a graph is shown, so one can easily, or the observer can easily understand the various insights of the data easily. Then comes your symbolic data. So what is a symbolic data? If you see that symbolic presentation of weather data, that is, at some place there it is shiny, some place it is cloudy, some place it is raining, some place it is heavily raining with thunderstorms. So accordingly they have some symbols, and accordingly on the map they place those symbols. So such type of data is symbolic data. Sometimes you take example of maps in which they symbolize the type of soil available in the different region. So that type of data is symbolic data. Simply by seeing those symbols, you understood that this refers to this particular range. Okay, or the qualitative data. Then scale of measurement. That is, the data can also be divided on the basis of what is the scale of measurement of that data. So first one is the nominal data. So what is nominal data? In nominal scale is used for assigning numbers. That is, what happens in a nominal data, we assign numbers as the identification of the individual units. That is, individual unit in your data is assigned some numbers, and those numbers comes under the nominal data. Okay, for example, the classification of journals according to the discipline they belong to. Okay, that is, this is particular with the pathology journal, this is a parasitology journal, this is a animal genetics breeding journal. Okay, so accordingly they have been given 1 2 3 4 5 6 some numbers. Okay, and from those numbers you can identify that this particular journal is of this subject. Okay, although there is no relation, mathematical relation between those numbers with each other. It is not like that if one journal is given 2 number and other is given 4 number, so that 4 is 2 times the 2 journal. Okay, so these are simply used for the categorization. Okay, that is making the category and represent, that is what I have written here, that is they represent only the name of the category. Then comes your ordinal data. It indicates the ordered or graded relationship among the numbers. So there is ranking, there is a order, there is a gradation among the numbers assigned to the observation made. So these numbers cannot ranks of different categories having relationship in a definite order. Okay, that is, for example, we study the responsiveness of a library staff. A researcher may assign 1 to indicate poor, 2 to indicate average. That is, 1 it is indicative of poor. Okay, then 2 is indicative of average, then 3 is indicative of good, then 4 is indicative of excellent. Okay, so when placed in a order they have certain relation with each other. Although we cannot say that good is 3 times the poor, okay, or excellent is 4 times the poor, we cannot say like that. It is simply the ranking. Okay, although we can say that this average are better than poor but worse than good. Okay, so their plus minus can be done. So the ordinal data show the direction of the difference. They show the direction of the difference and not the exact amount of difference. Okay, so this is very important. Then comes your interval data. So what is the interval data? Interval data are ordered categories of data, and the differences between various categories are equal measurement. That is, if we order a data and the difference have equal measurements, that is, this 1 and 2 is poor and 2 and 3 is average, it does not indicate that they have equal differences. Okay, so in particular in this interval data, for example, we can measure the IQ of a group of children. After assigning the numerical values to each IQ of the child, the data can be grouped into the intervals of 10, like 0 to 10, then 10 to 20, 20 to 30, and so on. In this case, 0 does not mean the absence of intelligence. The children with IQ 20 are not doubly intelligent than the children of the 10, but they have a certain amount of value differences between one class to other. That is, there is a difference or interval of 10, 10, 10. Okay, so such type of data is interval data. Then comes the most commonly used data type of measurement, that is the ratio data. And it is the ratio data are the quantitative measurements. That is, the quantitative data is generally measured in terms of ratio, and Ratio data is the word we generally use in mathematics. That is, all the mathematical operations can be applicable on the ratio data. These all can be understood from this table by comparing this table. So I think that voice problem has been resolved to a greater extent now, because I am not getting again a query. Okay. So now this comparison among different level of measurements of data, that is, first one is the nominal. So what is the property of a nominal data? It makes the classification or the membership, and what you can say, either equal to or not equal to. That is, a member can either be equal or unequal. That is, two groups can be equal or unequal. This is the only mathematical operation you can do here. And how, for what it is used? It is used for grouping. And what type of statistical parameter we can apply on such type of data is mode. So then in ordinal, we can compare, we can make levels, and we can apply this greater than and less than. And one more thing you should understand over here is that successive level of measurement are incremental in nature and possess properties of its predecessor as well. That is, in a ordinal, you can also apply this equal to, not equal to, as well as greater than or less than. And they are, what for they are used generally, this ordinal data, for sorting the individual in increasing order or decreasing order. And what type of statistical parameter is generally being used in ordinal data is median. Then comes your interval. So interval are the differences you can calculate between the entities, and affinities also. Here you can do plus and minus in interval type of data, and they are simply yardsticks, and mean and deviation can be applied in the interval data. And then comes here the most applicable type of data, that is the scale data. It tells you about the magnitude and the amount of data available with you, and you can apply all the mathematical operations. You can apply equal to, you can apply unequal, greater, less than, plus, minus, multiplication, and division. And what type of advanced operator you can apply is ratio. You can also find out the ratio between the numbers, and geometric means, coefficient of variation, and even all the statistical parameters can be applied to scale or ratio type. So this mode, median, mean, deviation, everything can be applied to scale and ratio. Okay. So these are the different type of data. So for this particular nominal and ordinal, we have qualitative data. And for this particular this scale or ratio, we have quantitative data. Okay. So this is the difference between different type of data being measured and how they are being categorized. Okay. Now, the data can also be divided into two based on the continuity of the data. If it is a continuous data, or we can say that what we have already told you, that is the discontinuous and continuous, or qualitative and quantitative. So, continuous is quantitative, okay, which is being generally measured in ratio scale. So continuous data are infinite set of possible values. This I am telling from you the beginning. That is, infinite number of values are possible in case of continuous data. Say for example, between a range there are infinite possible values. For example, height of individual is not restricted to value like 155 centimeter. We can have 156, we can have 155.59, we can have 115.5.999. Okay, that is different values are possible in case of continuous data. Now comes your discrete data. Discrete data are finite data. Okay, they are not infinite set. That is, a particular value is being assigned in case of discrete, or potentially countable set. There they are being used when we used to count the individuals. For example, number of members in a library or number of students in your class. Okay, so it can be here an example of library is given. It can be 2575 or 2599, but cannot be like 2599.5. Okay, so they take a wholesome value, particular value, which is countable in nature and finite in nature. So such type of data is known as discrete. Now, data can also be divided into various types based on the number of characteristics. So there are three types of forms which can be on which a data can be divided into uh, univariate data. What is a univariate data? In your class, for all the students, if I am only measuring the height of the individual, okay, so that will be univariate data. If I will be along with the height, I will be measuring the weight of the students also. So that will be bivariate data. But along with the weight of the individuals, I am also counting upon the OGPA of the students. So that will be multivariate data. So if there is a one variable in a data, it is univariate data. If there are two variables in the data, like height and weight, then it is a bivariate data. And if there are three or more characteristics, then it is multivariate. Concentrate on this particular word, three or more. If a question comes that two or more, then it is not a multivariate. Then it is a two, then it is bivariate. If it is three or more, then it is a multivariate. Okay? So now coming, this completes our different types of data. Now we come to the properties of data. So what is properties of data? So reference to, if we take the reference of our definition already given in the box, we understood that the data have certain properties which it should met with. So one is the amenability of use, then other is the clarity, other is the accuracy, and last one is the quality of being the essence of matter. So we will be just discussing one by one these uh, properties of data. So first one is the amenability of use. So if we take that from the dictionary meaning of data, it is learned that data are facts, okay, and these facts are used in deciding something. So in short, data are meant to be used as a base for arriving a definitive conclusion. So what we are going to do with the data, we are going to arrive at some definitive conclusions. So they are not required if they are not amenable to use. So first of all, where is the origin of data? If they are amenable to use, then a data is generated. Otherwise, data is not generated. Their OGPAs are generated because they are going to grade you in BBSC and EH courses, and later on when you will be appearing for different interviews. So that is why this primary data has been generated by conducting the examinations. If this might not be, this OGPA is not amenable to be used, then what is the use of generating this data? So until unless there is amenability of use, a data is not generated. Okay. Then second one is the clarity. So according to core data definition, data is a crystallized presentation. That is, it tells you about the characteristic of the trait you are studying. So this means the data should necessarily display so essential for communicating the essence of the matter. So if this data is not clear about and is not communicating you that what is residing in it, okay, so that data cannot be used for further. So such type of data will not be of use at all. Okay, if we collect some data in which from which we cannot draw out some conclusions, so that will of no use. So there should be some clarity. That is, if there is our OGPAs, then we are clear that okay, this student is having this much of OGPA, so he is having this much of better performance as compared to the others. Okay, so this gives you a clarity about the data. Okay, now accuracy. Data should be real, complete, and accurate. So incomplete, unreal, or inaccurate data are of no use. So accuracy is thus an essential property of the data. If you are measuring a data, it should be accurate. If while measuring you are deliberately or indeliberately measuring inaccurate data, that will lead to the errors in your ultimate conclusions. So, a data is very necessary to be accurate to draw out the meaningful and right conclusions out of it. Okay, so then comes your essence. So in surveys you have seen that large quantity of data are collected which cannot be presented, nor it is necessary to present in that form. They have to be compressed and refined. So data so refined can present the essence or derived qualitative values of the matter. So, data in sciences consist of observation are made from scientific experiment. These are all measured quantities and they always have the essence of the matter. So, when we are conducting an experiment, say for example on the feed intake of the animals, so whatever data we will be generating that this much of roughage has been average amount of roughage has been consumed by the animals, this much of concentrate has been consumed by the animals. So as far as this taking of this feed, that data is showing you the essence of that particular matter. Okay, so this is very important that whatever you are studying, that data should represent the essence of that matter. Okay, now before a data can further be used, it should have some undergo some operations. Okay, so the fate of a data to provide the relevant accurate information as per the objective of the investigator. To obtain this meaningful information from data is generally subjected to following operation. And what are those operations? First one is the aggregation. So aggregation is nothing but the cumulation or adding up. Okay. So for example, monthly data are added up to form a consolidated annual cumulation. Many a times if you go to the farm, so you will see that monthly milk yield are being uh, cumulated from the daily milk records, and from the monthly milk records then the annual milk records are being cumulated. So we can tell that on a daily basis this much is the production, on monthly basis this much is the production, and on annual basis this much is the production. Okay, so generally this cumulative, when the data is aggregated, they are being represented in the tabular form in the form of percentages or some other values. So this aggregation is of very important, let it be crop yield or export values or your milk yield values or other values in statistics and census data, they are being cumulated or added up to represent you the data so that you can extract out the information from there. Okay, then comes your compression. So large amount of data are always compressed to make them more meaningful. Okay, and to present the essence of matter, it is necessary to compress data. So compressed data are manageable and can be grasped quickly. So it is simple technique, that is from major chunk of data, what you have to do, you can make some graphs and charts or tables so that this compressed data can easily be understood by its audience. Okay, then comes your refinement. So data requires processing or refinement. Okay, and when refined they are capable of leading to conclusions or even generalization. This refinement can discover new facts, and conclusions can only be drawn when data is processed, or until unless you process a data you cannot take out the conclusions. Okay, then comes your this is I think the particularly the last part of the data. And what is the scope of the data? Okay, you have a data. Okay, then what are the determinants of the scope of the data, what you are going to use out of it? Okay, so what are the different determinants that how a data can be used in different ways? First is the utility. So data has a great utility in their use in the growth of knowledge. So ultimately from the data you make out some conclusions and that enhances your knowledge. No research, investigation, experiment is possible without reference to data already existing. Okay, so for research, what you do, you have to generate new data. For decision making, you have to generate data, and this is the utility of this data. That is, from this data, you develop new decision making systems. You enhances your knowledge, and accordingly, our learning process advances. Then the size of the data. The size of data involves the coverage of subject under the study. Okay, that is how much data you are having. As the size of the data increases, it becomes more closer to the population. As the data of population covering documents, data banks, field surveys methods, okay, so they used to gather the data, and that data is the correct representation of the population. So there is some examples has been given here, like Indian meteorological department, they gather the data so that you can have meteorological uh, extrapolations, that is what will happen in next month and how this meteorological things will happen. Then survey of India, okay, then Indian statistical organizations, then national sample survey, census of India. All these are big data, and they are being kept to draw out the conclusions that where we are heading, and so that we can forecast that what is going to happen in the coming 10 years or 20 years, and that too very accurately. So without being having that much size of data, you cannot predict accurately. Okay, so size also entails that how a data can be used. A for forecasting and all these purposes, that this data has to be of a adequate size. Then comes your period. Then, particularly data collection for any research problem must indicate the time span, that from when it has been observed. Okay. So in science, because this weather data, because seasons, years, and then other geographical conditions and weather condition affect the research so much. So we have to tell that when this particular study has been conducted. Okay, so in particular, these are the various scope and the determinants of this scope of the data. If you are having information about the time when a data has been collected, then if you have a sizable data, the size of data is good. And then if you have this utility of data to a greater extent, so in that case particularly, this data can very well be used for generating the knowledge and enhancing our learning process. So this completes our data. So from the next session of this particular topic, we will be taking up this collection of data, and this collection of data, I will be sharing with you the YouTube link uh, for this particular topic. So as for now, I am just closing it, and we will be meeting at 4:15. Okay, for the next session. So thank you very much for patience hearing. Thank you.